Welcome, everybody. I know I stand between you guys and beer and dinner, so I will try to keep it brief. Amen, amen. So a little introduction about myself. My name is Ryan Pastor. I'm with Building Point Southeast. We are a Trimble provider. We do a whole slew of things in the industry, from hardware and software to what I do in VDC services. So that's a little bit about myself. Today we're talking about mixed reality and mobile scanning and how do you quickly verify work in place on a job site. So the first thing that we want to do is really define this extended reality, if you've heard the term XR. It's kind of this conglomeration of mixed reality, augmented reality, and virtual reality. So VR being that very immersive experience. If you've ever kind of been in it, you can even get motion sick if you're not flying around a model effectively. Augmented reality being where you overlay digital content on the physical world. If you think of Pokemon Go a few years back, you could kind of play that game in the real world and see the characters on your phone, just like you were playing the game. But mixed reality kind of takes the best of both of those worlds, brings you into that immersive experience, but you're able to overlay that digital content on top of the physical world itself and interact with it. Andrew talked a little bit about this earlier, but just quick overview again, the differences between photogrammetry, static scanning, and mobile laser scanning. So, at the bottom you can kind of see the relative speed and accuracy of all of those methods. So we'll be talking about mobile laser scanning throughout this presentation. So everybody in here is probably familiar with trade coordination. Kind of the brief history going back to the early 20th century. You had this master builder, essentially somebody that was the designer all the way through to the person putting the work in place. Being one company. So over the years that became segmented out, right? To where we have design teams and engineering teams and contractor teams and subcontractor teams. So the challenge with that obviously was the coordination. So clash detection isn't new. We've always been doing things on light tables with 2D CAD drawings. Even with hand-drawn drawings, you can do that on a light table to some regard, as long as it's dimensionally accurate. Moving all the way through to obviously 3D and BIM, where we're reserving this room in space. But we're also able to take this information out of it and say, add hangers, use a robotic total station to go and lay out the hangers, lay out sleeve points, things like that. So the challenge then becomes, how do we know what we coordinated and spent all these hours in doing in the virtual world? How do we know that it's happening in the physical world and being built properly? So, throughout the years, paper drawings are very cumbersome, big, to bring out a drawing board, you got to put out on a big table, start scaling from them if they don't have dimensions on them. Mobile devices kind of get us, kind of take the weight off, literally. You can pull up any drawing, you can, zoom in as close to you want. But it's still only 2D. A lot of applications, nowadays go to the exhibit floor, are starting to integrate the 3D content, but still it's kind of difficult to overlay. If you have that mechanical room in the middle there, you're kind of like looking up and you're, kind of doing more of a visual check, a very visual check. And it's hard to tell how accurate you can tell if something's in place using that method. And even more limited viewers have an actual augmented reality capability or a pseudo-augmented reality capability where you would just kind of hide the background and stand in a certain spot and just kind of move your device around. This one that you see here, they're using a big kind of essentially an anchor chip or some sort of marking device that actually goes in there, and that's what the model element ties to on the floor. So mixed reality ends up being the best solution. So you were able to go and overlay the virtual geometry on real-world objects. So this is done in a whole host of methods. Essentially, depending on the software, we can start to take these planes, and in some of the hardware, it's called a stabilization plane. And so it'll start to pick up different surfaces if you have a certain amount of, flatness on there. So you can start to say, okay, I've got a corner of a room. Here's the wall in the real world. Here's the wall in my room. Here's the other wall, the floor. And then essentially you're aligned to that point. So as you start walking around the room, granted that your device is calibrated correctly, and you have enough features to make sure that you don't have any drift in your experience. Anywhere that you walk, that you have a model element, you're going to be able to see it in the real world. The next thing is that it's a very immersive experience, so users feel a part of the model. In the middle, you can kind of see that that was an experience that Trimble was actually doing an expansion on their building and brought in, gave it to real-life construction workers, and their experience was, wow, I can see exactly what I'm, about to build, or something that I just built that isn't in the right spot, or hey, it is in the right spot. That's also useful information to know, right? So it provides also an intuitive user experience. So you just put it on and you walk around. There's an alignment that you have to do, and the software will get there as far as making that more easier on the users, but it's very intuitive. And then you also can cross-collaborate, not just between devices in the same space, but remote access and people that don't even have a mixed reality device. You can start to bring them into the mix if they just have a phone, Apple AR kit, and I'm sure Samsung has a similar concept there. So it's just a different way to interact with your complex 3D data. So the next slide is going to be kind of I know we're supposed to stay agnostic, but one of my pet peeves is, coming to these conferences and seeing all these cool, presentations and then going back home and wondering, like, how did they do that? I don't even know where to start my research, because if you just, Google mixed reality, you might not, pull up all this information. So feel free to take a picture of this slide if you'd like to do your homework later. So right now the Microsoft HoloLens 2 is coming out. The Trimble XR10, which I actually have a prototype version today, just for show, is here. The Magic Leap 1 is obviously out. They're a little bit aimed more at the consumer market. Google Glass did a little bit of research. They're still around. I think they've got a lot of lessons learned that essentially the consumer market just isn't ready. The consumer-wise, we're not, we don't see a lot of value in seeing content in augmented reality when we can just as easily pull it up on our phone. And then software, if you look down that list, you can kind of tell who everybody is kind of developing for right now. A lot of these partners are actually out on the floor, so go say hello to them and try it out. So this was a use case that we did, a fast-paced schedule, no room for variation from the plan. We knew that we were going to do 3D clash detection, but being an existing space, they didn't have that model. So we were hired on to perform the scan to BIM because not all the different trade partners and the GC had experience kind of coordinating around a point cloud. It's possible, but it takes a little bit more time. So, they felt that having the solid model objects for those elements was going to provide them a lot more value downstream. So, we were thinking, hey, yeah, let's use that. we're going to try mixed reality on this project. But we actually found some things. The 2 inches on the right, column lines were starting to be off, by up to 2 inches in the field in some places. And then as we were starting to develop the architectural model as well, that was one of our tasks. We found that the CAD drawing, I don't know, I think we were talking about it in the opening session, but essentially, they had to thicken the walls. They wanted to add, another layer of, gypboard to each side. But instead of going in CAD and moving all those lines, they essentially just fudged the dimensions. So we were building it based off of where the line work was, but the field was starting to build it based on where the dimensions were. So, the field was getting ahead of us, and they were also creating their own. You'll see from the next slide or so that they were not actually building things to correct angles and things like that. So we thought we were done before it got even started, but we actually were able to, in order to find what the problems were, we were able to use the HoloLens to communicate different issues to the design team, to the contractor team. So header in the correct location, awaiting wood blocking. So you can kind of see, and the experience is a little bit different. Obviously, it's a lot smoother, on the device itself. But you can start to see, the wall needs to extend a little bit further for that glazing installation. The other thing that we started to see, something that was in the field that wasn't in the model. So there was actually a soffit that we missed in the modeling phase. So that was important to get that back in there. And I'll explain how we kind of did that as well. And then the last example here, the header, needs to be verified. Hey, are we in the right spot? So the kind of the redemption, if you will, was that, we said, okay, the work in place, what's being built is the source of truth. So we said, okay, after that mixed reality walkthrough, that was kind of the decision that was made. So we said, how are we going to bring this data back in, knowing that we're under a fast, tight-paced schedule. It was about 20,000 square feet, to kind of do a static scan with all these studs up now. You're essentially having to do a lot more setups. So we decided, hey, I think we're going to be able to get enough, a rough idea, and the value that we're trying to pull out of it by just doing a mobile scan. So you can actually see this is like a stud view overlaid with the model view. So you can start to see right here, this angle is actually supposed to be what it was in the model, but they built it, based on, kind of where different start points were and things like that. On those, less than stellar set of drawings, from the wall layout, we were able to actually go through and, adjust some of these model elements on the architectural side because they were going to have implications on the overhead MEP coordination, ceiling layout. There was some ceiling details that kind of tied in overhead that we also had to model into there as well. And then the scan was also able to be used for different purposes. So this was a mechanical ductwork kind of protruding out the wall here. It's essentially 9 inches lower than it was supposed to be, and it actually turns out that that was clashing with the wood ceiling. So we were able to find, and do other QA/QC throughout that process that added a lot more value to the project. This next one was very similar. On the left, you can kind of see that was the existing condition. We went through, and essentially did a laser scan after it was gutted. And in the center there, you can kind of see this one we didn't really do any modeling around the structure, just because modeling of the existing structure because it was, pretty simplistic. Kind of a waffle slab. Everything was kind of at that one level. We didn't have any, not too many deep penetrating beams, things like that. So you can kind of tell we're We actually did model some, things that were kind of occluded, and didn't have a lot of data on. We would put some actual model elements in there. This one, we did the ductwork installation, or did the shop drawings in the fab at probably LOD like 350, 400, using Siskiyou parts and things like that. And so this is a walkthrough that we did, kind of a value-add service, mixed reality as a service, to basically do that quick QA, QC. It's kind of hard to tell if something is, if it's correct, but something like this, you can easily tell, hey, that, that duct is supposed to be a little bit further out, and we can start to have that conversation before, they close up the ceilings, and, we realized, oh, hey, it was supposed, we really need it to be where it was intended to be because of clearance or something like that, or, they probably ran into some issue in the field where that had to be, bumped out by a couple inches, and then we can actually, we can start to load other models in and say, hey, is that going to affect anything else downstream? Is there supposed to be conduits there? Is there supposed to be a light there that, maybe the field installer didn't realize when they were, moving it, inadvertently? And this last use case is more photos, but like I said, this is a plumbing QA/QC, mainly DWV, drainage waste vent, cast iron piping. It's really, when things are lining up on top of each other, and inside the mixed reality device, you can actually adjust it more through a transparency setting on the device itself. So if I'm looking to do a QA/QC, I'll bring the transparency pretty low. That way I can actually, see where those items are. So the way that it kind of renders out when you take a photo of it, you're not able to kind of really, play around too much with the transparency. But, when it lays on top of each other, like I said, if it's good, we want to know about it. And it also kind of gives us this, this kind of look into how installers prefer to install things, right? We had, I think, like a combination fitting there, but it looks like, instead they just took it down and, went to a Y and went straight to the fixture. So, things like that, we're able to start to see, as a modeling firm, hey, this is how they actually like to prefer to install it out in the field, which is, ultimately our goal is to, we're never going to have all the knowledge that a field, installer is going to have, but, this can help give us a little bit of insight into, how they think about things as well. So these were a few of the deficiencies, if you will. The one on the top left, so you can see we're aligned. That one's a little bit off, but it's a chase, so it's not that big of a deal. The floor drain is supposed to be right here, but it's actually a couple inches over, and we can tell that, hey, that floor drain was supposed to be, I think, for an ice maker, but the location that it's at right now is essentially sitting underneath that cabinet. So we had to essentially communicate that to the contractor, figure out what the issue may have been, and essentially go back upstream and solve it. This one, essentially we can see that we designed it to go a little bit off the wall due to the fire protection, but the field installers, obviously didn't feel like that was, it was easier to put it against the wall, but now that's going to clash with the fire protection guys. So, we had to have a conversation, on the coordination side of, hey, our field guys kind of went rogue on us. We've got to kind of take it and run. But kind of in closing, limitations and challenges. So open air environments, because we're projecting on a piece of glass, anytime you introduce an abundance of light, it's essentially going to wash out that screen. I've seen people essentially taping tinted film to the forefront, which is very viable and easy and kind of cheap. But yeah, bright environments. Computing power, I think, is the biggest thing. that I'm interested to see as the hardware progresses, because we'll talk in a second about file sizes and all that. But no support for scan data. For me, that's not a big thing. The whole use case is to bring it out into the field. And so if you're out into the field, you don't really need that scan data, in my opinion. So, but some people want that support, and it'll come with time. And it's mainly visualization for now. Being able to see like an RFI issue and communicate it straight back to like somebody's brain, like we'll get there. But right now, it's mainly used for say here's the issue, take a snapshot of it. Different applications will handle it a little bit differently, but ultimately, as we start to bring all that information and all the other presentations, and that information gets pushed downstream, we'll see that come. The other challenges and lessons learned was the model alignment was kind of difficult at times. File formats, depending on the software that you use, you have to make sure that you're using the right file format, and then file size, breaking the model into smaller sections, using a lower LOD. For example, if you're in Revit, instead of using the detail, bring it down to coarse. Takes a lot of that line work out of the element itself. I've done things where I also basically just strip out all the fittings and just, it's not going to give me the 100% detail, but obviously, if I got a pipe here and a pipe here and they're in the right spots there, the fitting's in the right spot, whether it's like a long sweep or a short sweep, then, if you're trying to look at that level of detail, obviously you're not going to see it there, but, and then kind of deleting or hiding, that non-critical geometry. So that's all I have. Appreciate it.